Hello. In this short video, I want us to focus on understanding the derivative. Like, what is the derivative? How do we understand it? How does it work? I want to dive just a little bit into this idea to hopefully bring some clarity, because we've been doing a lot of derivative, we've found a lot of rules, but what is it? Now, the first way you can think about a derivative, and I think this is a very valuable way, is that the derivative is a special limit. So when we defined the derivative of fx, we said it was the limit as h approaches 0 of f of x plus h minus fx over h, of course provided the limit exists. And so we needed to study limits in order to understand the derivative, because we studied all types of limits, lots of limits with roots and infinity and all sorts of different things. And so we got a really good handle on what a limit was. Then we could take that understanding of limits and apply it to a special limit, an interesting, a cool limit that we would then call the derivative. So that's one way of thinking about the derivative, is that, well, it's just a limit. It's a special limit, sure, but it's nothing more than a limit. Now, another way to think about the derivative is that it's a transformation. You might remember your transformations from pre-calculus where you have vertical stretches or horizontal translations. Well, a transformation is like one of those, but it's a bit more involved. We take the function x squared and we transform it into the new function 2x. And I'm going to show you on Desmos what this transformation looks like. So here we have the function y equals x squared, and the purple dots are going to represent the slopes of the tangent lines. You can see the little mini tangent lines there, and well, they're not very tangent. If I was to take the purple dot here and raise it up, you can see that the black line becomes steeper because it's got a more steep slope. If I move it down, you can see it goes down, and eventually if I move it into the negatives, we have a negative slope. Now let's try to move that purple dot so that the line looks tangent. I'd say about there, that looks like a pretty good tangent line. We can maybe zoom in just to confirm, but yeah, that looks pretty good. Let's look at the other dots and let's move them so that the lines look tangent. In particular, for these dots on the left, we have to move them down so we can give negative slopes. All right, well, let's move that last dot and see what we get. Well, it looks like a line has appeared. That purple line that just popped into existence is the line connecting all the purple dots. And if you were to come up with an equation for that purple line, you would indeed find the equation 2x. This is exactly what we did on our first day of calculus. So the derivative is a transformation because it transforms the green graph into the purple graph. Now the transformation is pretty involved. It involves picking points, finding slopes, plotting those slopes, but that is effectively what you're doing, transforming one graph into another graph. So let's look at another derivative. We know the derivative of sine x is cos x. Again, it's hard to see how that would be a transformation. It feels sort of random, but if we look at the Desmos exploration here, we should be able to see how it's transforming the one graph into the other. So here we have the same activity, but this time with the sine x graph in green. And if you notice, the tangent lines are all messed up, so we should probably move them around. This point over here needs to go down. Looks like this point should also go down. And then this one should probably go up a little bit. This point needs to go up, maybe to about there. And we just go ahead and start fixing these tangent lines so that, of course, they are tangent. And when you do that, well, you notice that this purple graph appears. If you were to connect all those purple dots, which represents the slopes of the tangent lines, well, you would get another curve, and if you notice that curve, the purple graph, is actually the graph of cos x. So you can see how the graph of sine x has transformed into the graph of cos x by plotting the slopes of tangent lines. So in conclusion, you could think of the derivative like a transformation. So as a meme, of course, the derivative of Optimus, right? You could think of it as Optimus Prime. It's a transformation. Maybe this will help you remember that when you're doing derivatives, you're taking one function and transforming it into another. Hopefully you enjoyed this video, and as always, thanks for watching.